Good morning, students, and welcome to a class in differential calculus. And in this video, we'll be focusing on the introduction and the basic concepts of pre-calculus so that we have enough information to understand the topic of calculus better. Now, in this video, we'll be learning what is calculus, why do we study calculus, and how do we derive the first principle, and how do we combine the concept of first principle with the concept of limit to find the first derivative of any point on a curve? Or in easy language, we can say, how do we find the slope of a given point on any curve using the concept of calculus? So without any ado, let's proceed further into our lesson today. If I ask you a basic question, what is calculus? Okay, what would you have to say? Well, the simple answer is it is a branch of mathematics that is concerned with the rate of change. Now, when we talk about rate of change, what is the rate of change on an XY plane or a 2D graph? When we talk about rate of change in terms of graph, all we can think of is the gradient, slope, and tangent, because that is the only change in Y and change in X we see on a 2D plane. How do we find out the gradient? Okay, so that's rise over run, or we can say the change in value of y divided by change in value of x, or we can also say y2 minus y1 divided by x2 minus x1. Now, I don't have to explain you this. This is basic linear graphs, okay? So you have to know this if you want to study calculus. So let's move on to the next slide. Okay, so why do we study calculus? We study calculus to find out the gradient of any given point on a curve. Now, how do we do this? We do this by differentiating from first principle. And this is the formula. And this is not just the formula. It is actually a process which is used to find the rate of change, which is the gradient on our XY plane. Now, these three are the must know if you want to understand calculus and how it essentially works. So number one is secant. Number two is chord. Number three is tangent. So let's start with the chord. Now, what is a chord? Chord is a line segment joining 2 points on a circle. So the line in blue is an example of a chord. What about a secant? A secant is a line intersecting the circle at 2 distinct points. So the line in green is actually a secant because it intersects. But a chord never intersects. It just touches 2 points on a circle. And at the last, what is a tangent? Tangent is a line which touches the curve at 1 point. So the only point of contact between the curve and the line is that 1 point. And this is the point where calculus starts, where calculus kicks in. So let's move on to the next slide. So the rate of change is the gradient, slope, and tangent. Okay. Now let's talk about straight lines. Let's go back to the basic concepts of linear graph. Okay. Now, in a straight line, if I ask you that I want to find out the gradient of this point A and point B. Okay? Now, how do we find out the gradient of point A and point B? It's very simple, right? So we find out the change in the Y followed by the change in X. Okay? Followed by the change in X. So we can say that the Y here is 6 and the Y value here is 3. So the change in y, which is basically delta y, will be y2 minus y1, which is equal to 6 minus 3, which is equal to 3. So that's the change in y, and change in x is 4 minus 1. So we can say that the change in x is equal to 4 minus 1 is equal to 3. To find out the slope, we can say m is equal to delta y divided by delta x, which is change in y and change in x. So change in y is 3 and change in x is 3, so we get an answer of 1. Now, understand what is this 1. This 1 is our slope, right? Now, this is basically the proportion of change in y and change in x. And the gradient of a straight line is always constant. Let's take this 2 points C and D. Okay, so let's take point C and point D. So the change in y between C and D is 14 minus 10 is 4, and 12 minus 8 is the change in x, which is also 4. So delta x is 4 and delta y is 4. Now, if you divide 4 by 4, we get the same answer, which is 1. So what does this 1 tells us, this 1 actually tells us that what is the proportion of change in x with change in y. So here, the change in x is equal to the change in y. That's why our slope is 1, because change in y divided by change in x, they both the same numbers. That's why we get a 1. So that 1 tells that if there is one change in x, there will be one change in y. That's why at every point on a straight line, the gradient is always going to be constant. And the rate of change between 2 points on the line. Now, when we talk about gradient, we talk about the rate of change between any 2 points. Now, it can be any 2 points because change can only be derived by comparing 2 quantities. Now, here we compare the 2 quantities of y and 2 quantities of x, and that's how we find out the slope. Okay? Now, but we cannot say that the same applies for the curves. Let's take this example. Point A, B, C, D, and this is our curve. Now, at the curve, the gradient at every point will not be the same. Will not be the same because it does not share the common properties of a straight line. Now, if the gradient here is something, the gradient here will be something else. Here will be something else. Here will be something else. Okay? So, just to make you understand that a straight line and curve do not share common properties. Okay, so point number 1, gradient of a curve is always changing. And point number 2, that the rate of change at one point on a curve. This is what we have to focus. So the gradient on a curve is basically the rate of change at one point. That's why we say instantaneous slope at one point. We will study further, don't worry about it. But remember that you have to know what is the difference between a straight line and a curve, without doubt. So let's move on. First principle of differentiation. Calculus is used to find out the gradient of any point on a curve. And we do that by using the first principle of differentiation, and this is the formula. Derivative of y with respect to x is equal to limit h approaching 0, where the fraction is function of x plus h minus function of x divided by h. Okay? Now, let's learn how do we denote the first principle. How do we denote the derivative? How do we write? When we talk about dy over dx, keep in mind that this is not a fraction. Okay? If you think it is a fraction, that's a big mistake. Now, what is this called? This is called the derivative of y with respect to x. Now, let me explain what it means. In a simple way, we can say that it measures the rate of change or instantaneous change or slope of y at a given point x. Okay, now let's have a look at this curve. Suppose I have to find out the slope of this point, right? Just this point. Now, in order to find out the slope of this point, what we have to find is the instantaneous change in the value of y, which is the derivative of y, with respect to x. That means at any given point x. This is the most important part. Let me show you how the first principle works. Okay, so first thing, let me draw a secant. Correct? And so this is the value of x. Correct? So there's something x here, and this is the second value of x. So this is our input. The range is from this point to this point. Now, let me say that suppose if this point right here is called h. At this point, we can say that the value of x will be x plus h because there is h involved. Okay? So, and if there's an x value, there has to be a y value as well. So let's talk about the y value. So the y value is basically the function of x because y is the function of x. So we have an x coordinate and we have a y coordinate. So let's write down the xy at this point. So the x is just x and y will be the function of x. Okay? Now let's go back to this point. So what is x value at this point? The x will be x plus h combined because at this point there is x and this is h. So at this point the x value will be x plus h. And as we know, y is a function of x plus h, so we can easily write that the y will be a function of x plus h. Because basically y is a function of x, so we'll write x plus h, and y will be the function of x, which is x plus h. So these are the two coordinates, okay? So I can easily say that this is our x value, and this is our y value, and this is our x value, and this is our y value, correct? Okay, now, we can say that this is x1, this is y1, and this is x2, and this is y2. Now let's go back to the formula of slope. We say m is equal to y2 minus y1 divided by x2 minus x1. Okay, correct? So what is m equal to now? Our y2 value is function of x plus h. So let's write down function of x plus h. And then we have a minus, and our y1 value is f of x. So we can say function of x. Divided by, what's our x2 value? Our x2 value is x plus h. So we can write down there x plus h, and then we have a minus, and then what is our x1 value? That's just x, so minus x. So what can we do more? So this is a plus x, and that's negative x, so we can cancel it out. So what left is h, so we can write function of x plus h minus function of x divided by h. So that's how we get our first principle of differentiation. Okay, now this is just the first principle, and it is not yet enough to find out a slope of any given point on a curve. Now what we have to do is we have to learn limit. Because if you don't combine the concept of limit with the first principle, calculus is not going to work for you. So on next slide, we will see what is a limit. So let's go on. Okay, so this is the first principle, and there we go, limit of h approaching 0. Now, when we say h approaching 0, what do we mean? So let's take 2 points, point number 1 and point number 2 on a graph. Okay, and let's say that this is our h, and we're talking about h approaching 0. Now, when we say h approaching 0, what do we mean? We mean that the value of h is decreasing eventually. It's going down step by step. It's decreasing. It is going towards 0. That's what we mean. It is approaching 0. Okay? Now, so this is h. So when h is approaching 0, but keep in mind that it cannot be equal to 0, because if it is equal to 0, then we cannot differentiate. We need those 2 points so close to each other that one can barely see the difference. So what happens when h approaches to 0? Now, let me tell you here. Our h is actually, this is our h, correct? So at this point, right here, at this point, our h will be equal to 0, because that's the point where h is starting. So h is from 1 to 13. So that is the value of h, and at this point, h is 0, because it is just getting started. So as we move towards h, the value of h keeps on decreasing to a point where we can say that it is approaching 0. So when we say h approaching 0, it means the point in our case is moving to the left-hand side towards its value where it is equal to 0. But keep in mind, approaching 0 doesn't mean it is equal to 0, but it gets too close to that point where you can barely see the difference. Okay, so that's the point. Okay, as we can see, this is the point, and they are so close to each other that we can say that the value of h is almost equal to 0, but keep in mind, not equal to 0. That's not what we are looking for. Okay, now how it works on a curve. Let me show you an example of a parabola. Okay, so that's how the curve is formed. So as we reduce the value of h, the point keeps on shifting or sliding downwards to the left-hand side because it is a parabola. Okay, it depends on what kind of a curve you have, and it slides, it comes so close to these 2 points that we can barely see the difference, and that's how we find out the derivative of this point. Okay, now suppose if this is a curve, okay, and this is a point, and this is another point. Now these 2 points are so close to each other that the value or the difference between them is almost equivalent to 0, and that's why we say when h approaching 0. So this is the concept of limit. Now, how can we use limit and the first principle together to find out the slope of any given point on a curve? So if I zoom this for you, you can have a look, right? Now this point has been shifting, sliding, 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 and it gets so close to this point where the h is almost or approximate to 0, and at the same time not equal to 0, because there has to be a gap. If there's no gap, we cannot measure the rate of change, and that's why we study calculus. Now let's see that how we can combine the concept of limit and first principle to find out the instantaneous slope of any point on a curve, which basically means the instantaneous change in y at any given point of x. Okay, now let's combine the concept of first principle with limit to find out the first derivative of any given point on a curve. Okay, so how do we do this? So that's our formula, and let's take a curve and a graph. Okay, now let's say I want to find out the derivative of this particular point A. Now what will I do? The first step, I'll draw a secant. Second step is I will reduce the value of h by 1 unit. Now what happens when h gets reduced by 1 unit? The secant will change its location. So from that point, it will tilt downwards to a new location, which is our line number 2. Now, what happens when the h reduces or when the value of h decreases? 2 things happen. Our gradient will change because it is a different line, and the length of the chord of chord 1 and the length of the chord of chord 2 is not the same. The length of the chord will keep on decreasing as the value of h approaches 0. Have a look. Now we reduce the value of h by 2 units, so the secant will shift. And as we keep on reducing the value of h towards 0, in other words, when h approaches 0, and when h is almost equivalent to 0, then the first secant line is going to turn itself into a tangent. And that's how we find out the slope of any given point on a curve. How do we do this? This is done by turning the secant, which is this line, into a tangent. Now, why do we do this? Understand. So the curve and the straight line, they have just one common point, and that's called the tangent. Now, what happens when this line turns into a tangent? Now, let me show you. So this is a curve, and this is our tangent line, and it touches the curve at one point. Okay? Now, at this point, the slope of this tangent and the slope of this curve will be same. So we can say at this point, the slope of this point of this tangent line is equal to the slope of this point on the curve. And that's why we study differential calculus. So thank you so much for tuning in, and I'll see you guys very soon on another video. Thank you so much for your time.